Next, the F-104. We consider that the cost and performance of the model was excellent, and I guess after some 2,500 of them having been built around the world, we consider the F-104 series a success. The story of the F-104 began during the Korean War. Kelly Johnson visited frontline squadrons in 1952 to determine what characteristics the next generation of U.S. Air Force fighter planes should possess. At that time, the Republic F-84 Thunderjet and North American F-86 Sabre were being outperformed by the Soviet-built Mikoyan MiG-15, particularly at high altitudes. Predictably, the reaction of the pilots was a demand for greater speed, altitude, and rate of climb, even at the expense of maneuverability, armament, range, ease of maintenance, and creature comforts. Johnson returned to Lockheed with the notion of a lightweight, fast-climbing, high-speed, high-altitude daylight interceptor. The idea was not exactly a new one, but in pursuing it, Johnson was leading Lockheed onto financially risky ground. The concept of the specialized interceptor had been explored from time to time since World War I, and it had usually been discredited. The problem lay in the interceptor's lack of operational flexibility. No one wanted a combat plane that performed one mission well to the exclusion of all other missions. Johnson was convinced, however, that he and his staff could produce such a quantum leap in aircraft performance that the Air Force would have to take notice. If one word could describe the airplane that Kelly Johnson and his team designed in 1952, it would be extreme. The Model 83, as the F-104 was originally known, was created for the sole purpose of flying faster and higher than any other fighter in the world. It was, in essence, the smallest fuselage and wings that could be constructed around the most powerful available engine, one pilot, and the minimum necessary fuel and armament. The F-104's maximum airspeed of Mach 2.2 was dictated primarily by the shockwave propagation in the air intakes, by the thermal limitations of the aluminum alloy from which the airframe was constructed, and the amount of stress that the canopy attachment points could take. Air pressure could pull it from the cockpit at speeds above Mach 2.2. To handle temperatures generated at high speeds, the airframe would have to have been built of titanium, rendering it far too expensive for mass production. The F-104 was the first aircraft to be powered by the then new 14,800-pound thrust General Electric J79, an engine that was to set a new standard for power-to-weight ratio. The jet engine air intakes on the F-104 were fitted with movable semicircular shock cones designed to adjust the airflow at various speeds. Such devices came commonplace on jets in later years, but were unheard of prior to the F-104. The shock cones were considered so secret that the air engine intakes were completely hidden under aluminum fairings when the Starfighter was first exhibited to the public on April 17, 1956. The engine was not the only revolutionary component in the F-104. The plane's principal armament of a single 20mm cannon may have seemed puny, but it was a very special gun. The Starfighter was the first aircraft designed to use the General Electric M61 Vulcan cannon, a 6-barreled, electrically operated Gatling-type gun that could fire an unprecedented 6,000 rounds per minute, a rate of fire that could use up the F-104's complement of 725 rounds in just over 7 seconds. The Air Force was understandably dubious about the effectiveness of a gun fired from an airplane that was flying as fast as a bullet. Its operational requirement therefore stipulated that the F-104's armament should be augmented with yet another new weapon system, the heat-seeking AIM-7 Sidewinder air-to-air missile. A single Sidewinder was mounted on a rail on each wingtip. The Starfighter's T-shaped tail was also unprecedented. The configuration was arrived at after evaluating no less than 285 different designs. By far, the most astonishing feature of the Starfighter was its wings. In an era of swept wings and broad delta wings, Lockheed broke with convention by giving the F-104 tapered wings of a low aspect ratio that were remarkably small. Unlike most aircraft designs, the F-104's wing format was chosen solely for efficiency at supersonic speed, without any consideration for lift, maneuverability, or ease of handling at lower speeds. To compensate, the entire leading edges of the wings were designed to pivot downward to increase lift for takeoff and landing. Lift was also augmented by ingenious trailing edge flaps that had high-pressure air vented from the engines below across their upper surfaces. With a thickness at the wing root of 4.2 inches, a great deal of design ingenuity was necessary to develop aileron and flap actuators small enough to fit inside them. The edges were so sharp that special covers had to be installed over them to prevent ground crewmen from injuring themselves. Another unusual feature of the F-104's wings that was not obvious from the outside was that they were not connected to each other by a continuous main spar, but by a frame encircling the fuselage. There were penalties to be paid for the Starfighter's speed. The tiny, thin wings that endowed the F-104 with its high performance also gave it a blistering stall speed of 198 miles an hour. To help stop the Starfighter, Lockheed gave it a powerful drag chute. It also had a tailhook, similar to those found on carrier-based fighters, but an unusual feature on a land-based fighter. Since the wings could accommodate neither fuel tanks nor landing gear, both had to share the limited space available inside the narrow fuselage. As a result, the F-104 was never to be noted for its endurance, even with extra fuel tanks fitted to the wingtips. The F-104's design also gave it a high wing loading, which rendered its maneuverability less than ideal, particularly at subsonic speeds. In the 1950s, however, it was generally believed that high-G subsonic dogfighting would no longer be a decisive factor in the future air battles, which would be fought at high altitudes by supersonic fighter planes armed with guided missiles, aircraft such as the Starfighter. That supposition would be rudely contradicted in the coming decades over Vietnam, the Middle East, and in the Indian subcontinent. Lockheed test pilot Tony Livier flew the prototype XF-104 for the first time on March 4, 1954. The airframe was ready before the J-79 engine, so the XF-104 was first flown with a Wright XJ65W-6 engine. Even though the J-65 only produced 10,200 pounds of thrust, 31% less than the J-79, the XF-104 attained a speed of Mach 1.79 on March 25, 1955, becoming the first fighter to exceed 1,000 miles an hour. The XF-104 was eventually succeeded by 17 service test YF-104As, with J-79 engines. Kelly Johnson's faith in the Starfighter concept was vindicated when the YF-104A became the first aircraft type to set both speed and altitude records. Major Howard Johnson climbed to an altitude of 91,249 feet on May 7, 1958, and 4 days later, Captain Walter Irwin attained a speed of 1,404.19 miles an hour. The aircraft also demonstrated an incredible climb rate of more than 60,000 feet per minute. The Starfighter's altitude performance was so impressive that Lockheed later built 3 NF-104As equipped with auxiliary rocket engines and reaction jet controls, like those on a spacecraft, for operation at altitudes so high that conventional controls were no longer effective. Apart from everything else, the F-104 was one of the most exciting-looking aircraft in the world in the mid-1950s. The Starfighter combined unparalleled performance with an appearance that was so extraordinarily beautiful and wholly original. The U.S. Air Force ordered 155 production F-104As in 1955, a number that was raised to 722 in 1958. So many problems remained to be ironed out, however, that the first 35 fighters were diverted to the flight test program. In 7 years, 49 of the 153 that were eventually built were lost to accidents, a staggering 32%. 18 pilots were killed during the same period. In addition, operational experience with the F-104A was raising questions about its limited armament, range, maneuverability, and versatility. Lockheed responded to criticism of the F-104A with a more versatile fighter-bomber version. Designated F-104C, the improved Starfighter's once pristine lines were cluttered up with external hardpoints for up to 4,000 pounds of bombs, missiles, and fuel tanks. F-104Cs were used in Vietnam by the 435th, 436th, and 476th Squadrons of the 479th Tactical Fighter Wing from 1965 to 1968. But Vietnam was not really a suitable venue for them. Since there was nothing for them to intercept, there was no opportunity for the Starfighter to be used to its best advantage. The F-104C also demonstrated that it was still as dangerous to its own pilots as the enemy was. The 435th Tactical Fighter Squadron lost 5 starfighters to enemy action in Vietnam, but lost another 6 in accidents. In 1958, West Germany, whose Luftwaffe had been resurrected 2 years earlier, was in the market for a supersonic multi-role fighter. They wanted an aircraft able to perform air defense, reconnaissance, interdiction, close support, maritime strike, and even nuclear bombing missions. Despite the fact that the Starfighter had been originally designed as a specialized interceptor, Lockheed managed to adapt it to meet all the Germans' requirements as the F-104G. It incorporated a redesigned airframe, a more powerful version of the J-79 engine, a larger tail, an internal navigation system, improved radar, and 5 hardpoints for external stores. Over the course of the next 2 decades, it became one of the most widely used fighter types in the world. In NATO alone, Starfighters served as the air forces of Canada, Norway, Denmark, West Germany, the Netherlands, Belgium, Italy, Spain, Turkey, and Greece. West Germany, the largest user, acquired more than 600 of them. The F-104G became, for all intents and purposes, the first Eurofighter. In addition, a further 238 F-104Gs were manufactured in Canada by Canada Air as CF-104s. A total of 1,585 F-104Gs and CF-104s were built, including two-seat conversion trainers. That was more than 5 times the number of Starfighters built for the US Air Force. The last production version of the Starfighter was the F-104S, an all-weather interceptor developed by Italy in 1968. Air Italia produced 205 F-104Ss for the Italian Air Force, plus an additional 40 for the Turkish Air Force. The last F-104S was completed in 1979, a quarter of a century after the flight of the first Starfighter. Lockheed offered one final development of the F-104 in the late 1960s. Called the CL-1200 Lancer, it differed from the Starfighter in having a longer fuselage carrying more fuel, a larger shoulder-mounted wing, and a conventional low-set tailplane. The Lancer came along too late to gain acceptance and never got beyond the mock-up stage. The F-104 was the product of a period when air combat was expected to be waged at ever higher speeds and altitudes. Whatever faults the aircraft had are directly traceable to that of the early 1950s philosophy. By the time the Starfighter became operational, that trend had begun to reverse itself. Today, air combat is often carried on just above the ground. Considering the fact that it had originally been intended as a specialized interceptor of high-flying bombers, Lockheed did a remarkably good job at adapting the F-104 into a multi-role Eurofighter. The F-104 deserves a place in the pantheon of American aviation achievements as the first combat aircraft to fly at double the speed of sound. It also deserves recognition for the part it played in NATO's air defense during the Cold War, and for its role in resurrecting the European aerospace industry. Kelly Johnson, in summarizing the F-104 in a paper released on June 18, 1957, precisely noted, "It is very difficult to see where added high speed is worthwhile, and it appears that the development of armament, radar, and fire control systems is the most fruitful field for our research efforts over the next 5 years. Above all, it deserves to be remembered as the breathtaking missile with a man in it." The U-2s. We underran our contract on that, and gave back the government over 20% of the first contract. It was a success. It was the first time when the Skunk Works went into production. Because of security and other reasons, we, for the first time, made more than 2 of anything. And we made the complete line of the U-2s and the other versions that have come from it. High-altitude strategic reconnaissance philosophy was first articulated during late 1952, when an Air Force major by the name of John Seaberg placed on papers ideas he had for achieving sustained flight at ultra-high altitudes. Seaberg had noted the new generation of turbojet engines could be mated to an aircraft with extremely efficient high-aspect ratio wing and achieve cruising altitudes far in excess of any aircraft in the service. On May 18, 1954, some 2 weeks after returning from Washington, D.C., a new proposal for a high-altitude cruise aircraft from Lockheed's preliminary design organization arrived on Seaberg's desk for review. Johnson's own insights into the beginnings of the aircraft are only thinly recounted in his U-2 log. December 1953. We started an investigation of wing area modifications and stripping procedures to modify the F-104 airplane to get the maximum possible altitude for reconnaissance purposes. Seaberg and his fellow right field engineers spent 3 weeks evaluating the Johnson proposal.
In the early 1950s, the United States had a real requirement to overfly Russia to find out the status of their development of long-range missiles. There was no airplane in the United States or in the world that could safely overfly Russia at that time. Lockheed made an unsolicited proposal to Trevor Gardner, the Undersecretary for Research and Development for the Air Force, on a very specialized airplane. We promised to build within 8 months 20 airplanes for $22 million, including spares, that would do the job required. The program was turned over to the CIA, who then chose Mr. Richard Bissell, an economist, to run the program. Richard Bissell became a very good engineer, and he not only was our director on the U-2 program, but he also followed through with the development of the Mach 3 Blackbird. When I first met Kelly, I had been working for nearly a year for Allan Dulles. I joined Allan's organization early in 1954. Toward the end of November, I was summoned one afternoon into Allan's office, and I was told, with absolutely no prior warning or knowledge, that one day previously, President Eisenhower had approved a project involving the development of an extremely high-altitude aircraft to be used for surveillance and intelligence collection over denied areas in Europe, Russia, and elsewhere. We had, on the basis of Kelly's proposal, an almost impossible schedule to meet. It was almost impossible for Lockheed, but I can assure you that it was also an extremely tight schedule working within the bureaucracy.
Given the temporary design number CL-282, it consisted of a slightly modified XF-104 fuselage and associated vertical and horizontal tail surfaces. Most noticeable, however, was the deletion of the XF-104's distinctive trapezoidal-shaped wings and their replacement by a high aspect ratio wing of extraordinary span. Designed into the latter were 4 integral fuel tanks completed by a 5th tank in the fuselage. Together, these provided a total fuel capacity of 925 gallons. After a thorough but rushed review, Seeberg and his staff rejected the CL-282. Johnson, after receiving word of the negative report, would note, June 7, 1954, received a letter which turned down our proposal on the basis that it was too unusual, that it was a single-engine aircraft, and that they were already committed to the Martin program. When the Air Force informed Johnson of its decision to eliminate the CL-282 from contention, Johnson decided to pursue funding through other channels. Johnson's timing could not have been better. Numerous sources had begun to input data into the U.S. intelligence community, indicating the Soviet Union was moving ahead quickly with an extensive family of liquid-fuel nuclear warhead-equipped intercontinental ballistic missiles. On November 19, 1954, Johnson would make the following log entry. I met with the Government Advisory Board. They wanted to be reassured that our proposal was technically feasible. They believed my story that we could make such an airplane in the time mentioned, and also asked why Lockheed seemed to be the only one who could do this job. General Putt answered graciously that we had proven it 3 times. As it turned out, this was a momentous decision. In one master stroke, Johnson, with Gross's blessing, had transformed the virtually non-existent Skunk Works into not only a full-scale advanced design and engineering team, but a production facility as well. Secrecy had mandated the change. Eisenhower had agreed that funding and direction of the project, to be codenamed Aquatone, would be through the offices of the CIA rather than the Air Force, with Richard Bissell to direct it. Earlier on November 9, 1954, Trevor Gardner had visited with Lockheed President Robert Gross and Johnson at Lockheed's Burbank facility. Following a review of the full-scale U-2 mock-up, Gardner gave an official confirmation of project approval and a directive to go ahead with the prototype construction. Johnson promised that the first Aquatone aircraft be in the air no less than 8 months after the first metal was cut. On December 10th, the design team was frozen, and on December 20th, Johnson noted in his log, "Working like mad on airplane. Initial tunnel test successful." Among the unique weight-related accomplishments of the design program were the following. Wing weight was kept to an almost unbelievable 4 pounds per square foot. The landing gear was a bicycle arrangement with the heaviest component consisting of a single main strut. The tail assembly was attached at the center fuselage by only 3 bolts. The side opening canopy was manually operated. The control system was unboosted. Hydraulically actuated systems were kept to a minimum. There was no cockpit pressurization, and there was no ejection seat. On the morning of August 4th, 1955, Johnson, Ernie Joyner, Glenn Fulkerson, Bob Murphy, and several other Skunk Works personnel watched as Livier climbed into Article 341 in preparation for its first real flight. Given the call sign Angel 1, the aircraft was to be chased by a company-operated C-47, with Johnson and test pilot Bob Mathieu as observers. Customers also had been brought in from Washington, D.C., as they arrived at the test location by transport just prior to Livier's takeoff. Livier recalls the first takeoff and climb, taking place at 3:55 p.m. It went perfectly, and he encountered no problems or difficulties during the ascent. Leveling at 8,000 feet, he spent 45 minutes cycling the landing gear, deploying and retracting the flaps, exploring stability and control characteristics, checking engine temperatures and exhaust pressure ratios, and practicing power-off stalls. There were no malfunctions of any kind. Livier completed a total of 20 flights in the Angel before being transferred back to the F-104 and other Lockheed flight test programs on September 1st. Additionally, Livier became the first pilot to take the aircraft to 50,000 feet. The latter required the use of a partial pressure suit. This had forced Livier to go through the Air Force high-altitude training program. When he completed the curriculum at the age of 42, he was at the time the oldest pilot to do so. During his initial flight test period, the Air Force, at Johnson's recommendation, assigned the innocuous U-2 designator to the aircraft as its formal military alias. The flight test program during the remaining months of 1955 progressed smoothly. December 1st marked the U-2's first-year anniversary, which Johnson duly noted. "We have built 4 flying airplanes, have the 9th airplane in the jig, and have flown over our design altitude any number of times. We have trained the crews, and we are developing the Bakersfield factory. It's been quite a year." On June 19, 1956, CIA pilot Carl Overstreet departed Wiesbaden on the first operational flight. After overflying Warsaw, Poland, and returning via Berlin and Potsdam, he landed without incident and delivered to the U.S. intelligence community the first ever surreptitiously taken U-2 photos. The results were spectacular. The quality of the imagery generated by the Type B folded optics camera was everything the CIA had hoped for. Resolution, contrast, and quality were far beyond anything previously seen. Baker, of Harvard University and an astronomer by training, was one of the leading lens designers in the US during the 1940s and 50s. By now, Soviet diplomatic circles were impacted. The U-2 flights had been tracked with little difficulty by Russian radar, and the Soviet government was embarrassed by the ease with which the aircraft were able to penetrate Russian airspace. The military repercussions were great, and in a communique dated July 10, 1956, the Soviet ambassador to the US in Washington was asked to deliver a formal protest to the US government and request that the overflights cease. In responding, US diplomats denied that any military aircraft had been involved in such activity. This was, of course, true, as the CIA was a civilian and not military agency. During 1958, the Soviets began to gather momentum in their efforts to develop an effective U-2 countermeasure. The SA-2, an improved surface-to-air missile eventually codenamed Guideline by the West and equipped with a warhead that had a kill pattern with a diameter of about 400 feet, was pushed into service, and for the first time, threatened the U-2's high-altitude dominance. Though the estimated 2% probability of a kill was low, for the first time, the U-2 was forced into taking the new SA-2 launch sites into consideration. By the end of its third year of operation, the U-2's intelligence gathering ability had become the single most important tool in the entire US intelligence community arsenal. CIA U-2 operations were not confined to the Soviet Union during this period. During late September of 1956, Gary Powers flew across the eastern Mediterranean and gathered intelligence data on the positions of British and French warships as they prepared to aid the forthcoming Israeli invasion of Egypt. Further flights followed during the Suez Crisis and later during crises involving Syria, Iraq, Saudi Arabia, Lebanon, and Yemen, all to gather intelligence data on military activities and the eternal warring between those two various Mideastern countries. Additionally, U-2 overflights of the Zhejiang and Kangxi provinces in China began on December 6, 1958. On May 1, 1960, the U-2 was thrust into public spotlight when one flown by France's Gary Powers was shot down by Sverdlovsk by a surface-to-air missile. Captured, Powers became the center of the resulting U-2 incident, which embarrassed Eisenhower and effectively ended a summit meeting in Paris. The incident led to an acceleration of spy satellite technology. Remaining a key strategic asset, U-2 overflights in Cuba in 1962 provided the photographic evidence that precipitated the Cuban Missile Crisis. On October 22, 1962, President Kennedy made his now famous speech revealing publicity that Cuba had acquired an extensive offensive weapons capability including MRBMs and IRBMs. In an unquestionably threatening tone, Kennedy declared that any Cuban missile launch would be regarded as an attack by the Soviet Union on the US and that massive retaliatory action would result.
It shall be the policy of this nation to regard any nuclear missile launched from Cuba against any nation in the Western Hemisphere as an attack by the Soviet Union on the United States, requiring a full retaliatory response upon the Soviet Union.
During the crisis, a U-2 flown by Major Rudolph Anderson Jr. was shot down by Cuban air defenses. On October 26, communications with the Soviets indicated that they would begin dismantling the Cuban missile sites. On October 28, this was confirmed. The Cuban Missile Crisis, due in no small part to the photographic intelligence provided by the U-2 surveillance program, had come to an end. Frequent Cuban overflights continued. They were still in progress when President Kennedy, remarking, "I must say, gentlemen, that you take excellent pictures." As surface-to-air missile technology improved, efforts were made to improve the aircraft and reduce its radar cross-section. This proved unsuccessful, and work began on a new aircraft for conducting overflights of the Soviet Union. In the early 1960s, engineers also worked to develop aircraft carrier-capable variants, U-2G, to extend its range and flexibility. During the Vietnam War, U-2s were used for high-altitude reconnaissance missions. In 1967, the aircraft was dramatically improved with the introduction of the U-2R. Approximately 40% larger than the original, the U-2R featured underwing pods and had improved range. The phasing in of the U-2R over Vietnam led to the phasing out of the remaining Air Force U-2Cs. The last of the original U-2Rs was delivered from the Skunk Works Palmdale facility during December of 1968. As Johnson would note in the log, "We are rapidly running out of work on this program." This was joined in 1981 by a tactical reconnaissance version designated TR-1A. The introduction of this model restarted production of the aircraft to meet the USAF's needs. The U-2R and TR-1 were critical contributors to the Desert Shield and Desert Storm operations. They flew with a variety of sensors for high-speed resolution photography, radar mapping, and low-light observations. Intelligence agencies, field commanders, the Pentagon, and even the President used this information to identify military targets, estimate enemy troop strengths, and make battle damage assessments. In the early 1990s, the U-2R fleet was upgraded to the U-2S standard, which included improved engines. A production-configured re-engined U-2R completed its qualification phase of flight test at Palmdale during late 1993. 3 U-2Rs incorporating the engine and other upgrades were officially delivered to the Air Force from Palmdale to Beale Air Force Base, California on October 28, 1994. The upgraded aircraft were officially designated U-2S in the single-seat configuration and U-2ST in the two-seat trainer configuration. A total of 37 U-2Rs will be brought up to the new standard by the time the retrofit program ends during 1998. NASA's ER-2s will also be upgraded starting in 1996. Despite its advanced age, the U-2 remains in service due to its ability to perform direct flights to reconnaissance targets in short notice. Though there were efforts to retire the aircraft in 2006, it avoided this fate due to lack of an aircraft with similar capabilities. The Jetstar made 2 of them. They were a success as far as the prototypes went. When it was handed over to our Georgia division, here is a case where it wasn't handed over good. It was almost completely redesigned, went to 4 engines instead of 2. The cost almost killed us in the end, but as far as the prototype part of the program goes, it went well. During the latter part of 1955, it became apparent to the Air Force that its aging and somewhat electric utility transport and twin-engine training aircraft fleet was in need of a replacement with contemporary hardware. Many of the aircraft then in use for these missions could trace their origins back to the pre-World War II period. All were powered by reciprocating engines. Compounding the Air Force's problem was a post-Korean War funding shortfall that severely restricted new aircraft acquisitions. Nevertheless, the service elected to move ahead with long-term plans under the aegis of its UTX and UCX specifications. In order to do this, it required that the companies submitting their proposals also would be willing to fund their respective prototypes using their own money. Concurrent with its August 1, 1956 request for proposals, the Air Force made it understood that, if funding constraints were lifted, it would order up to 300 of the winning design. Making the new aircraft doubly enticing for manufacturers was the prospect of corporate and commercial sales beyond those to the military. Kelly Johnson later would note, "With the military as a ready prospect for such a sizable order, we pulled out all stoppers. We assembled our technical teams, studied the requirements, drew up plans, designed and built." While the new model CL-329 was conceived, engineered, and flown in less than 8 months, Lockheed had in fact spent some $7 million during the preceding 13 years studying large jet-powered transport aircraft that involved technology advances directly applicable to its forthcoming utility and training aircraft. During 1956, the Air Force informed industry there was a military requirement for a small jet transport to meet its UCX and UTX specifications. Johnson and his Skunk Works team, with corporate approval, immediately initiated preliminary design studies based on a small-scale L-193 variant. Accordingly, Johnson decided that in order to get the CL-329 into the air at the earliest possible date, it would be necessary to power it with the British-built 4,850-pound thrust Bristol Orpheus 1/5 turbojets. On the morning of Wednesday, September 4th, 1957, the first Jetstar taxied out onto the Edwards Air Force Base dry lake bed. At 8:58 a.m., the Jetstar became airborne for the first time. It had met Johnson's September 4th first flight deadline and had beaten by 2 minutes the predicted 9 a.m. departure time. Air Force Phase 2 testing was completed during February of 1958 using the first aircraft, and it was determined that the Jetstar had excellent flight and performance characteristics. On June 17, 1958, the first Jetstar embarked on a promotional trip to demonstrate its transcontinental range and high cruising speeds. Unfortunately, though the demonstration tour proved a success, national recession dictated the Air Force delay its plans to acquire the aircraft for operational service. As a result of the Air Force's intransigence concerning 4 engines versus 2 during January of 1959, Pratt & Whitney JT-12A turbojets were selected to power the Jetstar in its production configuration. On October 31, 1958, the Jetstar was picked by the Air Force over North American's NA-246 submission to meet the requirements of the UTX specification, which Lockheed had not originally planned to accommodate. During October, the Air Force announced its plan to acquire the Lockheed aircraft under the designation T-40A. Shortly afterwards, however, it withdrew the initial decision and awarded the contract to North American for what became the T-39A Sabreliner. Eventually, 211 trainer and light transport Sabreliners would be acquired by the Air Force and Navy, while Lockheed's Jetstar starved for orders. It was not until June of 1960 that an initial Air Force order for 5 Jetstars finally arrived. The first of these, by now referred to as the C-140A by the Air Force, was delivered during April of 1961. By January of 1962, Lockheed, having spent $100 million on the Jetstar program, was facing an $80 million loss. This was attributable to the Air Force's initial indications it would buy some 300 aircraft, when in fact, by mid-January of 1962, it had bought only 16. When Jetstar production ended during 1980, with the delivery of the 204th and last aircraft to the Iraqi government, Lockheed had lost a considerable quantity of money, but had learned some very valuable business lessons. The aircraft, regardless of its financial status, proved to be a successful corporate transport. Several versions eventually were built by Lockheed, including the C-140A, the C-140B, and the VC-140B for the military, and the Jetstar 6, the Jetstar 8, and the Jetstar 2 for the corporate market. Then came a number of Mach 3 types. The first one, which you'd be familiar with, would be the YF-12A. Its gross weight is still secret, but the cost performance was excellent. It was a success. Didn't produce any because there wasn't any threat. Not until the backfire bomber showed up. Of the many aircraft whose origins can be traced back to the Lockheed's renowned Skunk Works, none is more significant than the A-12. More than any other aircraft, this titanium masterpiece represented the apex of aeronautical engineering in its day. Not only at Lockheed, but at every significant aerospace engineering bureau around the world. Today, over 3 decades after its first flight, it remains the aircraft by which all others are judged. Project Suntan had given Kelly Johnson and the Lockheed Advanced Development Team engineers a significant opportunity to explore the attributes of hydrogen propulsion systems. Equally as important, however, Suntan also permitted the exploration of advanced airframes optimized for the first time to cruise at speeds well in excess of Mach 3. Soon after the U-2's first flight during 1955, Richard Bissell moved quickly to organize the research and development of follow-on systems, including what was to become the A-12. New studies, conducted under the codename Gusto, were initiated exploring the design and possible development of a totally new subsonic reconnaissance platform that would be designed from the start to incorporate the lowest RCS obtainable. The resulting analysis concluded that supersonic speeds, coupled with the use of radar attenuating materials and radar attenuating design, greatly reduced the chances of radar detection, though it did not reduce it to zero. Lockheed Aircraft Corporation and the Convair Division of General Dynamics during the fall of 1957 were to respond to a general operation requirement calling for a high-speed, high-altitude reconnaissance aircraft, but to do so without a formal contract or government funding. Johnson spent virtually every available minute working on the Advanced Aircraft program, which he sometimes jokingly referred to as the U-3. Project Gusto was now terminated, and a new codename, Oxcart, was assigned. Ben Rich would note that the A-12 was comprised of 85% titanium and 15% composite materials. Learning to work with titanium proved to be a major undertaking. The myriad breakthroughs pioneered by Skunk Works' manufacturing team in conquering this metal remain one of the great and unheralded successes of the most incredible program. Just a great deal of work with the many problems where you're trying to get this airplane built. Everywhere you turn, there is a tremendous problem requiring invention, new systems, and money, said Johnson. An official first flight, with appropriate government representatives on hand, now was made on April 30th. Nearly a year behind schedule, the aircraft became airborne for the first time. With Lou Schalk at the controls, the aircraft lifted off at 170 knots. The landing gear was retracted and climb was made to 30,000 feet. A top speed of 340 knots was reached during the flight, which lasted for 59 minutes. Following an uneventful landing, Schalk presented satisfaction with the aircraft's stability and the way it handled. On the second flight, on May 4th, the A-12 went supersonic for the first time, reaching Mach 1.1. Problems were minimal, and Johnson began to feel confident that the flight test program would progress rapidly, possibly recovering some of the time that had been lost in the drawn-out manufacturing process. The Cuban Missile Crisis now reinvigorated the program. The loss of Major Rudolph Anderson's U-2 over Cuba on October 27th underscored the increasing vulnerability of this subsonic platform when operating in denied airspace, and this was not lost on intelligence community offices involved with the overflight program. Successful execution of Oxcart now became a matter of highest national priority. At the end of 1962, two A-12s were in flight test, one powered by J-75s and the other powered by one J-75 and one J-58. A speed of Mach 2.16 and an altitude of 60,000 feet had been achieved. Flight test progress was still slow, and the engine delays and thrust deficiencies remained a major concern. Meanwhile, by the end of 1963, the CIA's A-12 flight test program had resulted in 573 flights totaling 765 hours. 9 aircraft were on hand at the test location. As noted earlier, during July, Mach 3 had been reached for the first time, and during November, design speed Mach 3.2 had been reached at an altitude of 78,000 feet. It should be noted that at this point on July 24, 1964, President Johnson made the first official announcement concerning the forthcoming Lockheed SR-71. While the A-12 situation vacillated back and forth between an operational commitment and a continued wait-and-see, flight testing of the YF-12A had continued. During July of 1966, Johnson wrote in the log, "We were directed to give up further flying of the YF-12As. Although we had proposed shooting down a drone at Holloman to get the effect of ground clutter for low-altitude targets." The following August 5th, he wrote, "We have laid off half of our test crew of the YF-12A and are maintaining only people to store the airplane or send it to Burbank. We are very near the end of this program." As late as January 26, 1967, Johnson made the following comments in the A-12 log. "We jointly agreed there would be just one round and not two. That seems to have been a very accurate evaluation, as it seems that 30 SR-71s give us enough overflight reconnaissance capability and we don't need the additional 10 A-12 aircraft." On January 5, 1968, an official wire closing down the F-12B was received from the Air Force. The YF-12A program would be formally ended on February 1st. In a final disheartening move, the Air Force, on February 5th, sent Johnson a letter instructing Lockheed to destroy the A-12 F-12 tooling. The final A-12 flight took place on June 21, 1968, when the last remaining aircraft, number 131, was ferried from the test location to Palmdale by CIA pilot Frank Murray and placed in storage. It would remain there for the following 2 decades. On June 24th, Johnson wrote, "While the intelligence community in Washington wanted very much to keep the A-12 program going, the present financial situation cannot stand the strain. It's a bleak end for a program that has been overall as successful as this." In summary, the A-12 program lasted just over 10 years from its inception during 1957 through its termination during 1968. The Skunk Works produced 15 A-12s and 3 YF-12As. 5 A-12s and 2 YF-12As were lost in accidents, 2 pilots were killed, and at least 6 had narrow escapes. In addition, 2 F-101 chase aircraft were lost with their Air Force pilots during the A-12 test program. The main objective of the program, to create a reconnaissance aircraft of unprecedented speed, range, and altitude, was triumphantly achieved. It may well be, however, that the most important aspects of the effort lay in its byproducts, the notable advances in aerodynamics, engine performance, cameras, electronic countermeasures, pilot life support systems, and the arcane art of milling, machining, and shaping titanium. Altogether, it was a pioneering accomplishment almost certainly never to be repeated in the history of aviation. The YF-12A developed into the SR-71, and in that case, again, the cost performance was excellent as we gave back to the government well over $19 million on the contract, and we consider it to be a success. On December 6, 1962, Kelly Johnson noted in his log, "Working on R-12 Universal Airplane, using company work order, can get no decision on any military version of the aircraft, but there does seem to be considerable interest in it." Johnson's rationale for this design was based on the premise that if he produced a single platform capable of performing the reconnaissance, recon strike, or intercept role depending on customer needs, it would greatly simplify production, and it eliminates the necessity of the Air Force deciding which version they want to buy. 7 days later, the Skunk Works was visited by several SAC personnel, and Johnson logged that they wanted to see what kind of a reconnaissance version would meet SAC's needs. We prepared our proposal for a 140,000-pound reconnaissance airplane capable of carrying 4,300 pounds of reconnaissance gear and gave it to Colonel Templeton with a forwarding letter. By March 18, 1964, R-12 construction was moving along with considerable rapidity, but contract negotiations had yet to be concluded with the Air Force. Johnson noted in the log, spent several days on the first R-12s. It is extremely difficult to get a reasonable profit for what we do, and no credit is given for the fact that we operate more cheaply than others. All activity relating to the R-12 and RS-12 configurations had, of course, been kept completely under wraps in the Skunk Works and within two confines of the involved Air Force and CIA offices. On July 24, 1964, however, President Johnson made his memorable announcement revealing to the world the existence of Lockheed's Mach 3-capable reconnaissance aircraft. I would like to announce the successful development of a major new strategic manned aircraft system, which will be employed by the Strategic Air Command. This system employs the new SR-71 aircraft and provides a long-range advanced strategic reconnaissance plane for military use, capable of worldwide reconnaissance for military operations. The Joint Chiefs of Staff, when reviewing the RS-70, emphasized the importance of the strategic reconnaissance mission. The SR-71 aircraft reconnaissance system is the most advanced in the world. The aircraft will fly at more than 3 times the speed of sound. It will operate at altitudes in excess of 80,000 feet. It will use the most advanced observation equipment of all kinds in the world. The aircraft will provide the strategic forces of the United States with an outstanding long-range reconnaissance capability. In August 1964, Kelly Johnson phoned Bob Murphy and asked him if he wanted to work on the new reconnaissance aircraft. At the time, Murphy was a superintendent in charge of D-21 drone production. He accepted the offer and was immediately briefed by Johnson, who said, "I want you to go to Palmdale and get Site 2 away from Rockwell. Hire the people you need. The pieces for the aircraft will be up with you on November 1st, and I want her flying before Christmas." The SR-71 was 107 feet 5 inches long and had a wingspan of 55 feet 7 inches and a wing area of 1,605 square feet. It stood 18 feet 6 inches high to the top of the rudders, and its gross weight varied from 135,000 pounds to over 140,000. The effect of thermodynamic heating brought about by the aircraft's extreme operating envelope was a major factor affecting its construction. Fully 93% of the airframe was built from titanium, while the remaining 7% consisted of laminates of phenylsilane, silicone asbestos, and fiberglass to help reduce the aircraft's RCS. The SR-71's forward fuselage has a circular cross-section and is of semi-monocoque construction. It housed the pilot and a reconnaissance systems operator, RSO, seated in tandem, the front undercarriage, fuel cells, and the air refueling receptacle. The delta wing features 2 prominent engine nacelles, each mounted at mid-semi-span and blended into the wings to further reduce RCS. 2 rudders mounted on top of each nacelle and canted inboard 15 degrees from the vertical also reduce the aircraft's radial signature. A large aft-moving spike extends forward from each engine nacelle, which helped to regulate mass airflow to the 2 Pratt & Whitney J58 engines. The maximum fuel load weight for the SR-71 was 80,280 pounds, and it was carried in 6 fuel tanks. Built to cruise an afterburner at Mach 3.2 and at altitudes in excess of 80,000 feet, the aircraft encountered extremely high airframe temperatures generated by thermodynamic heating. This, coupled with the diverse operating envelope of its Pratt & Whitney J58 engines, required the development of a special fuel which served not only as a source of propulsive energy, but also as a hydraulic fluid optimized in the engine hydraulic system to activate the main and afterburner fuel nozzles. On the ground, the aircraft was only half filled with fuel and then pressurized using LN2 to 1.5 psi above ambient pressure. Shortly after takeoff, the SR-71 would rendezvous with a tanker and get topped off. The air inlet control system was a major innovation used to exponentially increase the speed performance of all Kelly Johnson's so-called Blackbirds. At Mach 1.4, the outlet doors located in the exterior of the engine nacelle began to modulate automatically in order to obtain a prearranged ratio between dynamic pressure outside the inlet throat and static duct pressure inside the inlet cowl. At 30,000 feet, the inlet spikes unlocked and, at Mach 1.6, began moving towards the rear, achieving their fully aft position at Mach 3.2, design cruise speed. Cruising covertly during operational missions at speeds in excess of a mile every 2 seconds, it was essential that the SR-71's navigation system was both highly accurate and non-reliant upon external navigation aids to ensure the aircraft remained on the black line. At the heart of successful missions accomplishment, therefore, was the Notronics Astro Internal Navigation System, or ANS, designated NAS-142V2. Originally designed for the Douglas Skybolt air-to-surface ballistic missile, which was cancelled in 1963, it proved to be a perfect solution for navigating the SR-71 after a few modifications and updates. The system combined data from the internal navigation platform with a time datum accurate to within 5 milliseconds. Position updating was achieved automatically by astro-tracking at any one time 6 of the 52 most prominently visible stars by day or night, in effect using nature as a global positioning system long before GPS was developed. When the autopilot was coupled to the ANS via the AutoNav function, the SR-71 could be flown automatically, adhering precisely to a predetermined flight path that was loaded pre-flight into the ANS's computer memory. To facilitate maximum mission flexibility, the SR-71 featured 3 interchangeable nose sections housing either a high-resolution side-looking radar used for ground mapping and referred to as CAPRE, standing for Capability Reconnaissance Radar, an advanced synthetic aperture radar system, or so-called glass nose housing a palletized optical bar camera. The SR-71 did not carry any form of defensive weaponry save that which was generated electronically. ECM was and remains a highly sensitive area, where fast-moving technological advances meant that the SR-71's defensive electronic systems required continual updating throughout its operational life. Within the SR-71's cockpit, pressurization was allowed to fall steadily as the aircraft climbed from sea level to 8,000 feet, whereupon it remained constant to 25,000 feet. This ensured that the fuselage wasn't subjected to unduly high pressure gradients, which in turn meant that the aircraft's structural weight would be reduced. However, if pressurization was lost or the crew needed to eject, survival was dependent upon each of them wearing a full pressure suit. This requirement was enforced by Air Force Regulation 60-16, which stipulated that full pressure suits must be worn when flying above 50,000 feet. In 1977, the company developed the next generation of pressure suits. Designated the S-1030 series and featured a high level of commonality between the U-2 and SR-71 programs. Colored in old gold, the suit incorporated state-of-the-art textiles and was more durable and comfortable. Its 4 principal layers consisted of outer coverall of Nomex that was durable, tear, and fire resistant. The helmet, designated GN121394, was attached to the suit via a rollerball ring to enable the head to be turned. Oxygen was supplied to the crew members through holes situated around the helmet face seal. An airtight port located on the lower right side of the helmet enabled crew members to drink water via straw to ensure they remained hydrated, and a level of sustenance was also available in the form of liquidized food dispensed from a tube. Gloves completed the pressure seal and were attached via wrist hinges. Boots featured heel retraction strips that were connected by a cable to the ejection seat on entry to the cockpit. The complete pressure suit system cost about $130,000 a copy. Crews were issued with 2, and they lasted 10 to 12 years, undergoing a complete strip-down overhaul every 5 years and a thorough inspection every 90 days or 150 hours. December 22nd, the first SR-71, with Skunk Works test pilot Bob Gillen at the controls, took to the air for the first time. Departing from Lockheed's Air Force Plant 42 Site Facility 2 at Palmdale, it remained airborne for just over an hour and reached a speed in excess of 1,000 miles an hour, which, Johnson noted, is some kind of a record for a first flight. Though the SR-71's first flight had been completed with few difficulties, ongoing flight testing of the aircraft had not been comparably problem-free. The SR-71 flight test program, conducted at Palmdale, like that of its A-12 predecessor, was not without its accidents. The first, involving the third SR-71A, occurred on January 25, 1966, when Skunk Works pilot Bill Weaver miraculously escaped without losing his ejection seat. His back sealer, Jim Zwayer, was not so lucky and was killed. At the time of the accident, the aircraft was in a right turn, and then right inlet forward bypass doors were being controlled manually by Weaver. Though SR-71s finally were beginning to enter the operational Air Force inventory, the miscellaneous subsystem problems remained difficult to overcome. Tank sealing and range deficiencies continued to plague the aircraft, including those considered operational at Beale Air Force Base, and corrective action was painfully slow in overcoming them. By late 1967, all 31 SR-71s on order from Lockheed had been completed and delivered. By late September of 1969, the SR-71 was well on its way to a long, illustrious operational career. SAC already had flown well over 100 hot missions out of Kadena. NASA, for the first time, formally inquired into having an SR-71 for test purposes on December 29, 1970, when a query was received by the Skunk Works concerning possible use of the aircraft to launch test-scale models of the forthcoming space shuttle. On July 28, 1971, Johnson noted in a log, "Nothing new on the SR-71 operation. SAC made a 10-hour flight a short time ago on which about half the time was over Mach 3 and 80,000 feet. They flew 10,000 miles. The Vietnam War had successfully justified the SR-71's existence from the time of its operational debut during 1968 through 1973. Some 600 missions had been logged during the course of Vietnam operations, and the aircraft had logged an enviable record of dependability and mission success. Temporary deployment to forward operating locations worldwide were undertaken with considerable alacrity, and during the course of its service career, the aircraft overflew almost every major political and military significant hotspot in the world, gathering intelligence data of inestimable political and military value. The previously mentioned YF-12A speed and altitude records were eclipsed by the SR-71A during a series of Federation Aeronautic International monitored flights during 1976. As of writing this, all of these records still stand, including the world's absolute speed and sustained altitude records. During the late 1980s, as major international political and economic changes began to manifest themselves throughout the world, the U.S. intelligence community began to reassess priorities and, in particular, the way it was going to spend its limited financial resources. Virtually every program, including the SR-71, was reviewed with the intent of determining its long-term viability and, in particular, its simple cost-effectiveness. As a result of this review, and in light of advances in other sensor system programs, on October 1, 1989, all SR-71 activities, with the exception of crew proficiency training and associated training flights, were suspended while the Air Force awaited release of the 1990 fiscal year budget. When revealed several weeks later, funding for the SR-71 program had been eliminated. Accordingly, all Air Force SR-71 operations were terminated officially on November 22nd.
Good evening. Recent budgetary cuts for the Air Force have ended funding for the SR-71 reconnaissance aircraft program. Local civilian and military personnel had the opportunity to view the final functional check flight of the SR-71 as it prepared to return to the United States.
Rolling down Cadena's runway for one of the last times, the SR-71, nicknamed the Habu, performed a functional check flight in preparation for its last trip to the United States and into the pages of history. The atmosphere was charged with excitement as the flight crew, Major Jim Greenwood and Captain Steve Zaviniak, were assisted into 45 pounds of pressure suit. The physiological support technicians then conducted pressure tests on each suit and again performed these tests in the aircraft during free flight. The extra tests help ensure the suits will work in the event the pilots need to eject. The suits allow ejection at altitudes above 80,000 feet at speeds of Mach 3. After all pre-flight checks were done, the engines were started and the Habu came to life and soared into the skies of Okinawa for one of the last times. From Kadena Air Base, I'm Airman Rob Ivy.
Many of the Lockheed, Air Force, and CIA personnel who had been involved in the program during the preceding 24 years were on hand to say farewell to what many viewed as the single most significant military aircraft of the post-World War II period.
Tree 53.7, squawk 4454, tactical departure is on request.
And 4454 on the squawk for opinion 902. Yeah, opinion 902 ready to taxi. We'll be making the right turn out of parking, proceed down to Bravo.
Opinion 92, make right turn out of parking, runway 15, taxi via Golf, Bravo.
15 Golf Bravo for opinion 92. Off we go!
So begins a journey like none other I have ever taken. The traditional salute, to the dedicated ground crew that keeps this extraordinary bird flying. I know the camera crews are out there somewhere. Whatever happens, there'll be pictures. And there are the chase cars. Funny thing about the U-2. It is flown by one pilot, but it can't actually be flown by one pilot. That's because when the U-2 tries to land, its high aspect ratio wings do not want to stop flying. The only way to get it back to the ground is by effecting a complete stall at just the right height over the runway. So other U-2 pilots in chase cars called mobiles must race along and tell the pilot in the plane exactly where he or she is in relation to the ground at every moment. Look at those incredible wings. They are so long they have to be supported by little wheels on the ends called pogo wheels. The pogos have to cleanly drop off as soon as the plane is airborne and then be removed from the runway. That is why the chase car mobiles are needed on takeoff as well.
Beale Tower, stand by, sir. Beale Tower, we'll short runway 15.
Holding short 15, continue. At Bravo, holding short, ready.
Continuing 2, task for departure approved, runway 15 and 16 at 6, cleared for takeoff, change to departure.
Technical departure approved, cleared for takeoff, opinion 9-2. Alright, you ready to go?
Roger that.
Ready as we're gonna be. Alright.
We are cleared to go. I can't believe how the U-2 just pops into the air.
There's 3. That's 2 right there, 2.
Instead of giving the U-2 a typical fighter jet's 3-wheeled landing gear, Skunk Works cut back and gave the spy plane only 2, each placed in the center of the plane, akin to a bicycle's wheels. The decision shaved critical pounds off the aircraft's weight, helping it to achieve the desired altitude. When it came time to take off, 2 additional wheels would be attached to the plane, 1 on each wing. After takeoff, they would be dropped, and the plane would be free to ascend to the needed height. Landings were another matter. With only 2 wheels, the U-2's pilot would attempt to land the plane and slow it down without crashing its enormous wings into the ground. For this purpose, the pilot would be assisted by a crew of ground personnel, led by a chase car, which would drive after the landing plane and radio back information, such as its height and position, to the pilot. After the U-2 was slowed down enough, one of the wings could be tipped onto the ground to bring the plane to a stop. A titanium skid plate underneath prevented the wing from taking damage during this phase.
Inside out of the U-2 came off on stand country.
Opinion 7-2, check. Our opinion 7-2 is 9 DME final.
Opinion 7-2, Bill Tower. Report. Jams, traffic to follow the U-2 left base.
Opinion 7-2, report 5 mile final, follow U-2 approaching the left extended base.
7-2.
Type 3 U-2, and you're inside of 8 mile final.
Type 3. Union Type 3, your left extended base, 2 down, touch and go. Base Type 3, runway 151140, clear touch and go. Clear touch and go, Union Type 3.
Darping 79, aircraft mobile off Charlie.
Okay, 79, mobile, roger.
There was a day in 2011 when I'm told I was the highest person on Earth. Literally. On that day, I traveled to the space equivalent altitude of 70,000 feet.
Thanks so much. We'll see you tomorrow.
It was a voyage to the edge of infinity. For a few minutes that I will remember for the rest of my life, I stared through the frost formed on the canopy of our aircraft as deeply as I could into forever. I'm Gary Sinise, and this was my high flight.
Thank you so much.
There will be a time on Wednesday when you're the highest person on Earth.
Congratulations on that. Yeah. You got it. That'll be good for the wall. How are you? I'm Gary. Thank you.
Over the years, I've been blessed with many opportunities to visit our servicemen and women in the distant and often dangerous places where they live and work. In 2010, through a friend of mine who worked for the USO, I was invited to take a flight on the legendary U-2 spy plane. As enthusiastic as I was, I didn't fully realize all that a U-2 flight involved. By the time I boarded an airliner to return home, I would have met a group of people and flown to a place I would carry with me for the rest of my life. Beale is an 86,000-acre base that was opened in October of 1942 as an Army training site for armored and infantry divisions. It also served as a prisoner of war encampment during World War II. It transferred to the Air Force in 1948. The 9th Reconnaissance Wing is a highly specialized group of more than 3,000 personnel in 4 groups: the 9th Mission Support Group, the 9th Medical Group, the 9th Maintenance Group, and the 9th Operations Group. And Beale is headquarters for our U-2 program. The U-2 Dragonlady is one of the most amazing defense systems ever developed by the United States. She is a baby boomer, She was born in the 1950s when we began to realize just how little we knew about the newly emerging superpower, the Soviet Union. Once the USSR became a nuclear power, it became a matter of national security that we find a way to carry out reconnaissance over her. Doing that meant flying at an altitude higher than any defensive aircraft or surface-to-air missile could reach. That meant flying to a height considered the very definition of space. Design of such a watershed airplane became a priority of the legendary Kelly Johnson at Lockheed Martin's Advanced Development Programs, better known as the Skunk Works. Johnson was an aeronautical genius who developed over 40 aircraft, including the P-38 Lightning, the P-80 Shooting Star, the F-104 Starfighter, and the SR-71 Blackbird.
The U-2 program, like many successful military programs, began in the political environment. So after World War II ended, obviously political tension develops between the Soviet Union and the United States. There was very little known about the interior of the Soviet Union. So in 1953 to 54, the United States secretly ballots a program to produce an airplane that can fly above the suspected ranges of surface-to-air missiles at that time. And Clarence Kelly Johnson and his Skunk Works come out, and he says, I can take an F-104 Starfighter. I can take that fuselage, and I can take the wings off, and I can marry it to extremely efficient glider wings, high aspect ratio wings, long, thin wings that are extremely efficient up high. Their target altitude was 66,000 feet. So the first U-2 flies in 1955, and in 1956, we employed it operationally for the first time for the overflight mission of the interior of the Soviet Union. May 1st, 1960, when Gary Powers was shot down, did two things. One, it exposed the U-2 program. Khrushchev made it so. And the second thing it did, even in that particular airplane's demise, was confirm for us that the Soviets did in fact have missiles that could reach that high. And really through the ingenuity of its engineers, its pilots, we've taken this Cold War system and morphed how we employ it so that it becomes relevant and effective at pretty much all levels of war.
In the over 50 years of the U-2 Dragonlady's existence, barely 1,000 pilots have ever flown her.
So this wall is all of our solo wall. Every pilot that has soloed the jet, been alone and unafraid in the U-2, has his name and his solo number up on a plaque.
On another wall in Beale's Officers Club are the portraits of those who have lost their lives while serving in the U-2 program. This is truly sanctified ground. I was starting to understand what a rare opportunity I was being given. The chance to join the High Flyers Club, to go to the top of the Dragonlady's ride, 70,000 feet. That's twice as high as any commercial airliner flies. It's 40,000 feet higher than Mount Everest, the world's tallest mountain. If it all goes well, for a few incomparable minutes, I will be the highest human on the planet.
There you go, bud. Thank you for serving. Thank you. Squeeze in.
After all these years of traveling in support of our troops, it is likely that I've been on more military bases than many of those who actually serve in the armed forces. I'm impressed with every visit. Our bases are special places, islands of efficiency, productivity, orderliness, and civility. They are places that stick with you, that inspire you to do a little better and be a little better when you return to your own neighborhood. It was a great welcome to Beale. The first steps you take to get to 70,000 feet are toward the flight surgeon's office. This whole adventure can end right here.
So for a high flight or high altitude flight, things we look for include one, making sure that they'll fit into the ejection seat and can safely eject. So it's unique to each airframe, has different parameters, and so we just got to make sure that they're kind of meeting the standards for that, and that's the first thing we look at. Second one relates a lot to decompression sickness, the idea of kind of going from a high pressure situation up to a low pressure area. When that happens, we have gases in our body that will kind of off gas into our bloodstream, much like opening a bottle of Coca-Cola or product like that, where you can then get a bunch of bubbles that pop out. And as a result of that, it can lead to some problems that we would have to later use a hyperbaric treatment or a hyperbaric chamber to treat. And things we also want to look at is because gas expands, if there's ear sinus issues going on or they can't clear those areas, or if they have dental pain, dental pressures, again, that gas in those areas can expand and create a lot of problems. So we wouldn't want them to fly if we had those issues in the mix.
It's all good?
Yep.
To be honest, I do have a few problems with my ears and sinus, and I have never been to 70,000 feet before. I'm anxious to go, but I'm also a little apprehensive.
Mr. Sinise, this is your 1042. It's your clearance to fly. Go up to altitude and get on the plane.
Great, I'm good to go.
You're good to go, sir. Have a nice flight.
Great, thank you.
70,000 feet is a hostile environment for human beings. At that altitude, a catastrophic loss of pressure will cause your bodily fluids to begin to boil within seconds. So, there are some things you have to know and do before the Air Force takes you to the edge of space. Jay Ford will be the pilot for our mission. Confident, measured, calm, prepared, irreverent, funny.
Ejection, so our controlled ejection altitude, we want to be at least 2,000 feet above the ground. If for some reason the airplane goes out of control today, we want to eject immediately. We don't want to wait. No, but I'll let you know if that happens.
Please do.
Yes. Physiological incident, so if at any time during the flight you're feeling bad or funny, or you just have any questions about, hey, why do I feel this way, ask, let me know. So, bad news does not get better with age, and especially if it's, bubbles in your brain and spinal column. So we can do a little bit to fix those. So let me know, and if you're having any sort of GI problems, let that gas out as it's starting to build up. Don't hold it in, and keep holding it, and then things can get messy. Yeah.
Thank you. Appreciate it. Hi, guys.
Jump on in.
You want me in this one? All right.
I mean, everybody that comes out here is they're already a good pilot. So it's just a matter of...
You like being alone.
I do.
Because you're up there by yourself for how long? Could be
12
10
plus
hours?
yeah.
12 plus hours just flying.
So, you get used to it to a certain extent, but yeah, it is hard on the body. So, but the altitude that you're at, that will be inside in the airplane is about 28,000 to 29,000 feet. So if you think about it, you're sitting on top of Mount Everest for,
right.
You land and you feel like you got run over by a truck sometimes. So, and then
is that one gonna?
Yep, he's going out.
That one leaving?
Yes, sir.
How are you? I'm Gary.
Nice to meet you.
Thank you.
Darcy.
Thank you. Hi.
Welcome, sir. Name's Heather. Going to be teaching
Heather?
you about the full pressure suit today.
Fantastic. Thank you.
The physiology briefing is an attention getter, to say the least. I started learning what can happen to the body at altitude, and I was introduced to my newest best friend, my spacesuit.
Basically, open this guy up. You should be able to feel that it's open, and we go ahead and just add a little bit of air volume. Close off the suit just a little bit. You'll feel the suit. You don't want to fully inflate it, but just add a little bit of extra.
A loss of pressure in the airplane instantly makes the spacesuit my life support system. There are any number of dangers to humans at 70,000 feet, which can result in a very bad day. Will somebody be asking me how I'm feeling, or, you know, and I'm just describing what's going on with me?
Absolutely, yeah. So Jessica's gonna...
There's hypoxia, which is deficiency in the amount of oxygen reaching the tissues. At first you feel euphoric, just before you become totally incapacitated. Decompression sickness. This is what scuba divers call the bends. It too can be fatal. Altitude sickness. Illness caused by swift ascent to a high altitude, resulting in a shortage of oxygen, characterized by hyperventilation, nausea, and exhaustion. Heather Fox, the U-2 pilot who led the briefing, knows her subject and the symptoms all too well.
In about February 2009, was flying a op sortie over Afghanistan and started to feel bad with a decompression sickness. Basically started having symptoms of nausea, vertigo, a little trouble staying conscious, felt like I was going to pass out. So at that point, realized it was decompression sickness and started the turn towards my home base. Although ejecting at the location I was at probably would not have worked out very well. So at that point, the choice was to bring the aircraft back. It was about a 4-hour flight home, which was probably the worst 4 hours of my life, I must say, and just started the flight towards home. I will say that we've got folks up here doing this every day, and most of the time it goes well. So this isn't something that happens to a lot of folks, but it happened to me that day. But it's something we all know that's out there, and gladly do it to support the troops that we're supporting on the ground. It's something that we want to do.
They call getting fitted for your spacesuit integration, and it is a process.
So we're gonna get your helmet locked onto the suit. Bear with us. Okay.
They had some trouble fitting my face shield and seemed a little concerned about it for a while.
Now, so when you put the mask back on, just press on, because there's an aluminum strip around your face, so you might want to just press down so they actually conform to your face. Sorry? It should go like this.
And breathe. 1.1, 800. All right, that was successful. We're moving on. Yay!
The Barca lounges they use are really comfortable, but after you lie there for a few minutes, you have a little time to reflect. I remember one of the crew asking what I was thinking. To be honest, I was thinking, I'm glad my wife doesn't know all that's involved in this. You start getting ready to fly by pre-breathing pure oxygen. You do 10 or 12 minutes on the elliptical machine to really start sucking it in. This pre-breathing of pure oxygen eliminates the nitrogen from the blood and tissues, minimizing the risk of the bends I mentioned earlier. Once this process starts, you can't breathe normal air again. You have to hold your breath while putting your helmet on. Then carry the auxiliary unit with you, so you continue to breathe only pure oxygen. I was starting to get a bit tired, but my day was only beginning. To help me recognize the onset of hypoxia or other altitude-related illnesses, the team placed me in the altitude chamber.
3, 2, 1.
Testing for flight level 300. There you go, good job.
The first thing that I'm looking for is to make sure that he's feeling comfortable in the suit. He's comfortable moving around in it while it's fully inflated at altitude. That he knows where a lot of the things that Heather mentioned earlier today are, the vent air, the controller, how to be able to use that, how to be able to urinate, to be able to identify his hypoxia symptoms, because that's very important. There's not going to be anybody sitting back there with him, so he definitely is going to need to be able to identify those on his own.
Remember, you're talking to an actor.
Remember what I said about ear troubles? I really felt them in the chamber. Watch what happens to the beaker of water when the altitude simulated in the chamber reaches 60,000 feet. At that height, the air pressure is so low, your normal body temperature of 98.6 degrees will boil your own body's fluids. Things that make you think. Still not done. Now I have to learn the art of egress, getting out of the U-2 if something should go wrong on the ground or in the air. Of course, if you do find yourself hanging from a parachute at 70,000 feet, you also need to know how to control it. Ouch. This night, the leadership at Beale hosted a dinner for us. It is such an honor to be able to talk with these folks. They are the best in the world at what they do. I hope they understand the degree to which they all inspire and sustain the rest of us. All I can say is, God bless our troops. I retire a tired man. I feel like I've been drinking from an informational fire hose all day. It all kind of runs together. I don't know how much I actually remember. If something did happen, would I really be able to save myself? Well, there's no turning back. Tomorrow, I will visit a place I have never seen before and will likely never see again. It all starts to feel slightly surreal. I'm certainly ready to sleep. I only hope I can. In many ways, it's just another day at the office for my pilot, Jay Ford. Over a light breakfast, we went over the flight plan again. Essentially, we'll just be making a big loop over Northern California. The apprehension I took to bed last night has left me. Let's do this. Jay takes a final look at the anticipated weather. Great news. We're going to encounter severe clear. With a little luck, I might be able to see forever.
Hey, thank you very much. Thanks for serving the USA. You folks are awesome. It's great to be here.
Thank you for your support.
You bet.
Have a safe flight, sir.
Thank you. Bye-bye.
Is it possible to feel like a veteran without actually having flown in the airplane yet?
Folks, we got a timetable to meet. We got someone to get into a suit, 2 people actually. But last night I was able to tell Mr. Sinise that our motto that we always cheer in big groups is very fitting for him today. But for his high point today, we want to hook him up. Get him high! There you go. Have a great flight.
Thank you very much.
Yesterday, I had trouble with my gloves, my faceplate. I fumbled the fitting of those personal collection devices everyone always is so curious about when one is wearing a spacesuit. I worried about holding my breath long enough to put my helmet on and get the pure oxygen flowing through it. But today, well, I feel like I've been here before. In fact, I'm a little surprised at how much of my training I do recall. I'm ready. This is so cool. I admit it. I've always been a space groupie. When I was preparing to play astronaut Ken Mattingly in Ron Howard's Apollo 13, I got to meet Jim Lovell and a number of the astronauts. I met Gene Kranz, the flight director, who did so much to get that badly damaged craft and her crew home. I sat in the NASA mission control room where it all took place and let my imagination have its way. There was a space shuttle launch about the time we were starting to film. I just had to see it. I flew down to the Cape and just went out by myself to stand with the others who had gathered to watch. I was mesmerized. I watched the ignition, this great and terrible belch of smoke and fire coming from the huge nozzles at the bottom of the shuttle and its tanks. There was a slight delay while the sound and shock waves rolled across the water to the observation area. When they hit, I could literally feel them in my chest, clear to my heart. What an emotional experience. I'm truly sorry for anyone who did not have the opportunity to see a shuttle launch in person. As an actor, I'm used to playing parts. The spacesuit certainly brings back memories of roles I'd played. But this is no role. It is about to get very real. First, they integrate you into your spacesuit. Then you and your spacesuit have to be integrated into the airplane.
Press the button there.
I had to test my ability to reach those levers and handles I would have to pull if it became necessary to get out of the U-2 for any reason. There comes a moment when you have to arm your ejection seat. If you have to make an emergency exit, there is an explosive charge that literally blows your entire seat out of the plane with you in it. I was keenly aware that I was sitting on a bomb.
Your engine start is approved, cleared to Beale Airport as filed. On departure of flight runway heading, maintain flight level 230. Expect flight level 600 5 minutes after departure. NorCal departure frequency 353.7. Squawk 4454. Tactile departure is on request.
And 4454 on the squawk for Opinion 902. Yeah, Opinion 92 is ready to taxi. We'll be making the right turn out of parking and proceed down to Bravo.
Opinion 92, make right turn out of parking. Runway 15, taxi via Golf Bravo.
15 Golf Bravo for Opinion 92. Off we go.
So begins a journey like none other I have ever taken. The traditional salute to the dedicated ground crew that keeps this extraordinary bird flying. I know the camera crews are out there somewhere. Whatever happens, there'll be pictures. And there are the chase cars. Funny thing about the U-2, it is flown by one pilot, but it can't actually be flown by one pilot. That's because when the U-2 tries to land, its high aspect ratio wings do not want to stop flying. The only way to get it back to the ground is by effecting a complete stall at just the right height over the runway. So other U-2 pilots in chase cars, called mobiles, must race along and tell the pilot in the plane exactly where he or she is in relation to the ground at every moment. Look at those incredible wings. They are so long they have to be supported by little wheels on the ends called pogo wheels. The pogos have to cleanly drop off as soon as the plane is airborne, and then be removed from the runway. That is why the chase car mobiles are needed on takeoff as well.
Beale Tower, stand by, sir. Beale Tower, short runway 15.
Holding short 15, Opinion 92. Opinion 92, check. opinion 9-2, 1-5 at Bravo, holding short ready.
Taking Runner 2, task for departure approved, runway 15 and 160 at 6, cleared for takeoff, change departure.
Detective departure approved, cleared for takeoff, opinion 9-2. Alright, you ready to go?
Roger that.
Ready as we're gonna be. Alright.
We are cleared to go. I can't believe how the U-2 just pops into the air. An airliner needs 5,000 feet, a mile or so, to gain enough airspeed to take off. We're off in less than a tenth of that, only 400 or 500 feet. This U-2 is so smooth, I almost feel serene inside it. Yet the altimeter clearly shows it is climbing like a homesick angel.
NorCal, good morning. Opinion 9-2 with you. 3,000 climbing 230.
Opinion 902, Dr. Bird, ready to contact.
You looking outside?
Oh, yeah.
Trigger 5-1 ready.
Hey, and if you want to, you can open your T-block and do as you please at this point. You probably only get open a little bit. You get a pretty good amount of air through there.
It sounds strange to say it, but so far the flight feels like a relaxing breather from all the intense training I've been doing for it.
Oakland Center, good morning. Pinion 9-2 with you. 19.8 climbing 230 direct pinion.
Pinion 902, Oakland Center, climb out above flight level 600.
At or above 60, Pinion 9-2.
Jay has a mirror so he can see me. I didn't know until we got up there that that was the only way Jay and I could make eye contact. The altimeter continues to spin higher, higher.
So we're at almost 29,000?
Yep, just passing through 29, approaching 30. And we've been airborne for about 5 minutes.
That's fast.
Yeah. You went from the bottom of Mount Everest all the way to the top in 5 minutes, and I don't know, I think most people train for like 4 months to try and do that.
Your perspective really changes quickly. Man-made objects look like toys, if you can see them at all. Mountains start to look like sand dunes or snow mounds. Like Jay said, we are higher than Everest's 29,000 feet in no time. My cockpit sits about a foot higher than Jay's. That's why in level flight, I will be the highest person on Earth when we top out.
It's a pretty view up here.
Yes, it is. It gets better, too.
It's very special. So I can see how you get a little hooked on this.
Yeah, it's pretty darn special. Alright, so here's 45,000 feet. So we'll just continue to set the new personnel altitude records for you for the rest of the day.
That did not take long.
No. Alright, so there's 50,000 feet, or cabin altitude, so your body it's sitting at is at 24,000 feet, almost 25. So we'll gain over another 20,000 feet, but cabin altitude's only going to go up about another 5.
Very comfortable right now.
Yeah. Yeah, Pinion 9-2 passing 52,000 feet in the green.
Let's copy, in the green.
Copies in the green. Have a good flight.
Thank you.
Where are you from, Jay?
I'm from Georgia originally. I grew up there, born in Albany, down in the south, and we moved north of Atlanta when I was 2.
And you joined the Air Force when?
1998. So I went to the Air Force Academy out in Colorado Springs, and got my degree in computer science. And I went to Mississippi for a year for pilot training at Columbus Air Force Base, and then moved back to Georgia to Robbins Air Force Base down by Macon, and I was there for 4.5 years before I came here. Okay, well, fairly. Yep, there's 60. So we are now well above the space equivalent zone where if we didn't have the suit and we stepped outside, you'd boil to death. Followed shortly thereafter by freezing to death since it's almost minus 60 degrees centigrade outside.
Well, let's stay inside.
Yeah, I like that idea.
The U-2 is not an easy airplane to fly. The thinner the atmosphere, the faster the plane has to go in order for the wings to provide adequate lift. To maintain the required airspeed at 70,000 feet, the U-2 has to fly at the top edge of its speed envelope. If it drops by even 5 or 10 knots, the wing can stall. If that happens, the plane can become uncontrollable. U-2 pilots call this narrow operating window the Coffin corner.
This is incredible. Wow.
Yeah, it really is. It never gets old. Best view in the world.
Getting a little darker up there.
Yes, it is. Yeah, if you look up towards the sun, the sky is pretty much totally black up there. And then as you look closer to the Earth, where most of the atmosphere is, since we're above most of it now, you get that nice thin blue line of all the stuff that keeps us alive. But do stay hydrated.
Okay, I'll keep drinking. I'm making movies back here.
Awesome.
We are really up here. Wow.
Oh, yeah. Coming up on 66,000. Well, can you see that the Earth is indeed round?
It's amazing.
Yeah.
Just, you get almost speechless.
Yeah, using words to describe what it feels like and looks like to be up here is just not adequate.
It's just so smooth. It feels like a glider. I have to remember to stay hydrated while I'm up here. At 70,000 feet, we are twice as high as any airliner I have ever flown in. There is a vastness out there that I can feel to the depths of my being, but that I cannot describe in words. I fully understand why some astronauts have felt compelled to become writers and painters. At some point, even the prominent geographic features on Earth, like mountains and large lakes, become so small you almost feel like you are leaving them behind. When you travel to the outer edge of everything you have ever known, a sense of isolation starts to set in. I thought of the expression, Mother Earth, we use so glibly, and it suddenly seemed deeply profound.
Mom, I'm home.
Awesome. That's fantastic. Alrighty.
Incredible. Wow. Look at that reception party.
People are here.
I return to God's good earth a different person. I leave Beale Air Force Base a far richer man. Emerson wrote that there is no history, only biography. There are hundreds, if not thousands, of biographies attached to the U-2 Dragonlady. From Kelly Johnson to Francis Gary Powers to Jay Ford. There have been thousands of dedicated airmen on the ground that have kept her flying. There are countless gallant soldiers who are alive today because a U-2 was there to tell them what awaited them over the next sand dune. I leave Beale, as I leave so many military bases, with a deep and profound appreciation for those who serve our country in harm's way. Remember, this is an all-volunteer force. These are men and women who believe so deeply in the core principles of America, they willingly offer their lives to defend them. No greater love has any man or woman than to lay down his or her life for another. I thought about that up there on the purple edge of space with my life in Jay Ford's hands. And I thought about it when I touched back down on the ground after seeing the Earth in a way I had never seen before and will likely never see her again. I'm Gary Sinise, and that was my high flight. I wish you could have been there.
Hi, I'm Gary Sinise. I hope you enjoyed High Flight. And for information about the Gary Sinise Foundation's mission to serve and honor the needs of our defenders, veterans, first responders, their families, and those in need, please visit our website at www.GarySiniseFoundation.org. Thank you.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunk Works' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.